Hello, this is a chemistry video on enthalpies or heat of reaction. So I'm following the basic order of Brown, LeMay, Burston, and Murphy's Chemistry, the Central Science. We're in chapter 5, which is thermochemistry. The previous video to this introduced the concept of enthalpy, which is basically the heat either given off by a reaction or the heat that is absorbed by a reaction. And we want to go into a little bit more quantitative detail in this video. By the way, I have space up in the back in honor of the Falcon 9 SpaceX craft, which took off today, May 30th, 2020. We haven't had a NASA spacecraft in a long time, so we're back. All right, so enthalpies of reaction, which are also called the heat of reaction, what's given off or absorbed, symbolized by delta H reaction. Okay, right? Heats of reaction. So the delta H, the change in enthalpy, is basically the heat of the products minus the heat of the reactants, okay? Delta means change. So basically whatever you end up with, subtracted from what you started off with, gives you the change in enthalpy. So let's take the formation of water, where we have hydrogen gas and oxygen gas, and they come together to form two water molecules here in vapor form. Okay, so what is the change in enthalpy? Well, you need to absorb heat. It's an endothermic reaction. It takes in heat for this to happen. So it's negative, but basically it's going to take 483.6 kilojoules of heat in order for this to take place, because you got to suck in the heat in order for it to happen. So the heat of reaction for this equation is negative 483.6 kilojoules. This is, by the way, called a thermochemical equation. Don't have my second quote marks there, which is driving me nuts, but that's okay. We'll be okay. So this is a thermochemical equation because it tells not only the chemical equation, not only the reaction formula, but it also tells you the heat of reaction with it as well. Now, of course, it can go the other way too, right? We can take water vapor and break it down into hydrogen and oxygen. This is a exothermic reaction. It gives off, and you'll notice that it is equal and opposite. So we needed to absorb 483.6 kilojoules of energy and heat for this to happen. Whereas this reverse reaction is going to give off 483.6 kilojoules of heat. So you can see that it's equal and opposite when the reaction happens in reverse. Okay, some aspects of enthalpy that are introduced in this section. First of all, it is an extensive property. That means that the amount of heat is directly proportional to the quantity of reactant. And so the more reactant you have, the more heat either given off or absorbed in the reaction. As I just showed you, for enthalpy, it is equal in magnitude, but opposite in sign, delta H is, for the opposite reaction. So coming together to form water, it was endothermic and it was negative. Breaking water apart, it was exothermic and positive. So equal, the reversible process is equal and opposite in sign. Lastly, it is important to note what the state of the reactants and products are in. For example, whether it's a gas or a liquid. So for example, this particular formula ends up with water vapor. If you wanted to go on into water as a liquid, you would have to take into account the amount of heat that was involved in that process as well. So you have to pay attention to the resultant state of the product. Okay, lastly, this wasn't a very long section. This is what's called an enthalpy diagram. So here we have, I believe that's methane gas. So to get from, if you were to go from methane and oxygen to carbon dioxide and water, that is a endothermic reaction that requires 890 kilojoules. But if you were to reverse it and go from this, I'm not sure how you do it, back to methane and oxygen, that would take, this is a exothermic reaction, it would give off 890 kilojoules of energy. But this basically, this box diagram with reactants and products, depending on which direction you're going in, is called an enthalpy diagram. And there you have it, enthalpies of reaction, or heats of reaction.